Hi everyone, hope you're well and you've had a lovely weekend. Today we are going to carry on with our motion topic. So the first thing I would like you to do is pause this video and have a go at the practice questions, and I shall go through the answers in a moment. Just a reminder that this is going to use the equation. Speed is, oh gosh, you can't really see that, can you? Apologies, let's get rid of that. Can I draw up here? I can. Speed is distance divided by time. So yeah, pause the video, have a go at those questions for me, please. Okay, so let's go through the answers, assuming everyone's had a go at this. Just making it smaller. Question number 1, calculate the speed for the following journeys. So 1, speed is distance divided by time. 500 divided by 5 equals 100. Now remember, the units of speed are going to be meters per second, so m/s. Number 2, speed is distance again divided by time. Here's our distance, here's our time. So you've got 1000 divided by 100 equals 10 meters per second. 3, distance is 30,000 meters and the time is 30 minutes. Now I've put minutes in bold there because a reminder that you need to turn minutes into seconds. So how many seconds in a minute? There are 60 seconds every minute. So if you have 30 minutes, you have 30 times 60 to turn it into seconds. So when I'm working out number 3, I'm going to do distance, which is nice and easy, 30,000, divided by time, which is 30 times 60. Again, remember, we're turning that into seconds. Just getting my calculator out to do this one. So 30,000 divided by 30 times 60 equals 16.6 recurring. Rounding that up to 16.7 meters per second. Number 4, distance is 10 meters. The journey is 1 minute. So same idea, speed is distance divided by time. 10 divided by, and the time here is again in minutes, so we need to turn it into seconds. So you've got 1 times 60. So 10 divided by 60 is 0.16 recurring, and again rounding up to 0.17 there, meters per second. Number 5, calculate the distance. Now interestingly here it says in kilometres. Travelled on a journey that takes 5 hours at a speed of 70 kilometres an hour. Now normally I'd be saying, right, we need to convert, you're in hours, you're in kilometres, etc. But because they've asked for it in kilometres, and we're given time in hours and speed in kilometres per hour, we don't actually need to do any conversion, which is quite nice. So I am going to write down here, just because I've run out of space on that board. But you're working out distance, which is speed times time. You're going to do 5 times 70, which equals 350 kilometres. Number 6, calculate the time in hours taken for a journey where a vehicle travels at 90 kilometres an hour for 900 kilometres. So time is distance divided by speed is 900 divided by 90 equals 10. And again, I'm putting it in hours because I have asked for that. And I haven't had to convert because can you see that all of the units are very consistent? So I've got kilometres, hours, and kilometres per hour. So they're all the same. So when you convert is when you have something like meters, seconds, and meters per minute. Can you see you've got a random minute there? You don't want it there. You want everything to be the same. But here it is all the same, so I don't need to convert. All right, number 7. Look at the graph. Now, you have not done anything like this before, but this is what we're going on to today. So it's quite good to stretch your brain and see if you can kind of figure it out. Describe the motion during the journey. So let's look at this graph. You have distance up the side and you have time on the bottom. So whatever is moving, can you see it's moving for 40 seconds? And in that first 40 seconds, I'm just going to draw a line on the graph. Bit of a wonky line, but hey ho. Can you see it has travelled 30 meters per second? 30 meters in that first 40 seconds. So it's clearly travelling away from you, and it's travelled 30 meters in the first 40 seconds. Now, can you see the fact it's a nice straight line there? That means it's going at a nice steady speed. So it's going at a steady speed. Oh God, that says speed. My writing is appalling. Sorry. For 40 seconds. Reaches 30 meters. So all I'm doing is reading off the graph. Then can you see between 40 and 50 seconds, it's stopped. It's not moving anymore. So stops for 10 seconds. And then in the next 10 seconds, whoa, it's going really fast there. And you can see it's actually jumped up to 70 there. So then travels very fast for the last 10 seconds. And so what can I tell from that? I can tell when it's a straight line like these ones, where they're nice diagonal lines, it's moving at a steady speed. But the steeper the line, the faster the object is moving. When it's a flat line on a distance time graph, that means it's not moving, it's not going anywhere. So that's basically what we're looking at today. We're looking at something called distance time graphs. So if you can please title and date, it's obviously not the 10th of December 2019 when you're seeing this, so if you can please write today's date, that would be fabulous. And then let's crack on and have a look at our stuff today. So the next thing I'm going to show you are a load of different graphs. You do not need to write anything down on this. Instead, I'm going to show them to you and get you to try and figure out what do you think is happening in the graph, just like we did. And then I'll give you the notes afterwards. So don't worry about writing anything down for the next bit. I'll make it very clear when you do need to make notes. So all you need to do is look at these distance time graphs and think, okay, what's happening? So in this graph, you can see it's a nice straight diagonal line. Hopefully you're happy that they are moving at a steady speed. Next one. Can you see it's a flat line? What do you think is happening here? Hopefully you are aware. Oh gosh, how do I get rid of these ones? Okay, lovely. But it has stopped. Or another word for this is stationary, which just means the same thing, just means that it stopped. So, stopped or stationary for that one. Next one. Okay, so can you see here, you're covering a little bit of distance at the beginning, but at the top end, you are traveling a massive distance in a very short space of time. So what do you think we call that? What's happening here? Okay, so on this one, we say that it is accelerating. And I know that it's getting faster. Remember that was a word we used last lesson. So it's accelerating, it's getting faster, and I know that because it's getting steeper and steeper and steeper. So it starts off slow down here and then woo, really, really fast. So yes, apologies for getting rid of all of these. Okay, and the last one we're going to look at is the opposite. So what do you think is happening here? Okay, so hopefully you can see the fact that it's very fast to begin with and then slows down. So it's getting slower, and there is an official term for this, and that is actually called decelerating. So if accelerating is getting fast, decelerating is getting slow. So as I say, you don't need to make any notes for this. It was just a, have a little think. So the actual notes I want you to do, apologies, what have I done? How do I go back? Sorry everyone. Right, apologies, let's do this. Okay, so the actual notes I want you to take is this slide. So you can see there are 4 different lines here, and each one is a different action. So you've got slowing down here where it's very steep at the beginning and then it's getting shallower. You've got a very fast speed, you've got a steady speed, you've got the stationary there. And so I basically want you to do that. You see these grid lines here, you don't need to draw those on your graph. Okay, so I only really care about the shapes and the lines. So please, if you can draw the lines and label them, this is a distance time graph, that would be fabulous. So pause the video here and then have a go at that. Okay, so I'm hoping everyone's drawn that. That's brilliant. The next bit in this, your last bit of notes for today, is a couple of maths bits. And this is all about something called the gradient, which I know you've done in maths. So if you are thinking, I don't remember this, please find it in your maths book and read up, because you need to be able to do this in physics as well. So the gradient of a distance time graph gives the speed. Now I've put underneath a little bit of an explanation. The gradient is the steepness of the line. So if you have 2 graphs and one of them goes like this and one of them goes like this, are you happy that this one has got a bigger gradient because the line is steeper? So the gradient is that steepness. To work out the gradient, draw a triangle on the line and divide the change in y by the change in x. So if you can please pause that and write down those notes, and then I'm going to explain what on earth I mean by that for anyone who can't remember. So let's draw a graph, and this is time on the bottom and distance up the side. Oh, we've got to put units in, so that's meters, and this is seconds. And let's go 1, 2, 3, 4, 5 there, and 2, 4, 6, 8, 10 up the side. And let's have a distance, a nice little line that goes like this. Right, I hope that's roughly it. Okay, so I want to work out the speed of this line. Now to do that, I'm going to work out the gradient. So to work out the gradient, so I'm just going to write gradient equals speed equals, do you remember, change in y over change in x. Now some maths teachers might call this rise over run. You may have heard that. I like to go change in y over change in x. And by y and x, I mean the y-axis, which is obviously the distance one, and the x-axis, that got cut off, apologies, which is our time, the one on the bottom. So let's draw a triangle together. Let's change our pen, shall we? So I'm going to actually make the triangle the whole graph, because I can. You could make a teeny tiny triangle and draw one like that, that's okay. But if I make it the whole graph, I just feel like the numbers are slightly easier to read off. So I'm trying to make our lives a bit easier here. So now I want to look at my axes and find my change in y and find my change in x. So the change in y, it goes from 0 to 10. Hopefully you can see that on that axis. So my change in y will be 10. Then I'm going to look at the x-axis, and look, it goes from 0 to 5. Hopefully you can see that. So my change in x will be 5. So to work out my gradient, I'm going to need to move this, aren't I? Oh, for goodness sake. Sorry, I'm really trying to do this professionally, but it's not working. Okay, so gradient equals speed equals change in y divided by change in x. So that's 10 divided by 5. Which gives me an answer of 2. Now remember, it's a speed, so it is going to be meters per second. There you go, you've worked out the gradient. Now, on Google Classroom, I have put some graph paper sheets. And so what I would like you to do for me, please, is to plot a graph and then calculate the speed. So if you just get to do one of these graphs, that's fantastic. Don't worry, you don't need to do the other one for homework. It's just a case of trying to get one done. And again, I've given you the graph paper and you can do this on your iPad. That is okay. So perhaps screenshot this page and you are going to plot the graph, well, preferably both of them. But as I say, if you only get one, so be it. And once you have plotted your graph, which advanced warning is a nice straight line, I'm going to get you to calculate the speed. And remember, you're going to do that by doing the gradient, just like we've just gone through on that previous slide. So yes, have a go, screenshot this, plot the graph, and please let me know if you need any help. Right, thanks everyone, bye.